So like I said, this type of question, it's very important part of this chapter. You get this question in board exam many times to prove something is irrational. So this is one of the types where there'll be just a number like root 2 or root 5 or root 6, anything. So we'll start with root 2, okay? But before I go to this one, there is this theorem before this, which you need to know. Okay, so what does it say? Let P be a prime number. If P is a prime number, then if P divides A square, then P divides A also. Can you people understand what this is trying to tell you?
No, sir.
No, not making any sense? Okay. So let's break it down. Whenever something is complicated, we should always try to break it down into simple words. So they are saying that P is a prime number. So let's take a prime number, for example, 3. Okay, 3 is a prime number. If P divides A square, where A is a positive integer. Okay, so A is some positive integer, and I'm saying that P is dividing A square, means P divides A square means what? P divides it perfectly without leaving any remainder. That's what it means. Okay, so since we are taking an example of 3, I'm saying that 3 divides some number, square of some number, let's say A square, or let me write that A square over here. Now, if P divides A square, that means P will divide A also. So think of some number which is divisible, some square number which is divisible by 3.
Sir, 6 square.
Yes, okay, good. So 6 square. So some, like we are saying, I'm saying that 3 divides this 6 square. So it means that 3 will divide 6 also. That is what this thing is telling you. Okay. In other words, if P is a factor of A square, then P is a factor of A also. Does it make sense? See, I'm saying that A square is completely divisible by P. Does it not mean that A into A is divisible by P? See, both numbers are same. So of course, even if only one number is divisible by P, only then A square will be divisible by P, no? For example, let's take a number which is not divisible by that. So let's say I'm taking the same, P is my 3 this time, prime number is 3, and I'm taking a square of 7 square. Now, as you can see, since 7 is not divisible by 3, that is why 7 into 7 will also not be not divisible by 3. Because 7 is not divisible, that is why 7 into 7 will also be not divisible. So that same logic you have to apply. If A is divisible, only then A square will be divisible by P. Does that make sense? Or did I go too fast about it? Tell me, guys. Maybe read through this again once more. Why is everybody in silent mode? Did you people understand or did not understand? Okay. Okay, Harinarayan has understood. Pragati has understood. Ritesh understood.
Yes, sir.
Okay, Manoj.
Yes,
Yeah.
sir.
Okay, very good. Yes. So remember this, it will be useful in what we are going to prove next. Okay. So if somebody says that a square is divisible by p, it means that a is also divisible by p. Isn't that what we are telling?
That is always a prime number.
Yes, this rule is valid for prime numbers like p. We are learning a theorem, no? We are learning a rule. So this rule is applicable when p is a prime number.
Yes, sir.
Okay. Fine. So let's move on to the next theorem then. The actual theorem which you will have to prove, that proving that root 2 is irrational. So this proof, I think I recently did it and sent it to you people, right? Ritesh had asked me this doubt. Is that correct? I made a video for you people and I sent it. Let me see if I have that video. Yeah. So since it's the same thing, so instead of repeating, I'll just show you this video. Let's see whether it helps or not. And if more explanation is needed, I will explain that to you. So I'm going to play a recorded video right now. So it's not me talking right now. There'll be a video, okay? And of course, it's not a video with music. So don't expect a very, to be just like. So here we want to prove that root 2 is irrational. Hold on, guys. I think the audio is not all that great. Let me try to increase the volume. So tell me if you people are able to hear the audio. Okay. So here we want to prove that root 2 is irrational. So this we are going to do by contradiction. What that means is, first you assume that let that root 2 be rational, then you do some mathematical operations around it. And if our assumption, yes, tell me.
No,
Sir, your
sir.
background noise is heard. Sir.
Okay, okay. Yeah, I understand. The audio is not clear actually. Okay, let's do it again. Okay, not a big deal. Take this to our note. Just a minute. Hold on. Let me just. Okay. So confirm if everyone is able to hear me clearly. Is the audio fine now? There's no background noise over here, right? You can hear me?
Yes, sir.
All right. Okay.
Yes, sir.
Okay. So what I was saying is, if you want to prove that some number like root 2 is irrational, everybody knows that root 2 is irrational. How do you prove it? So to prove such a thing, what we do is we assume the opposite. Even though we know that root 2 is irrational, make a false assumption. Okay. Say that root 2 is rational. So if we are making this wrong assumption and then we do some mathematical calculations on it, so because our assumption was wrong, our mathematical calculations, whatever we do, it will lead us to making some mistake over there. Not a mistake, but basically it will lead to some conclusion which is not possible. Is that making any sense? Because I made a false assumption, when I do some calculation on it, it will lead to a result which is not possible. That result will tell us that, okay, whatever assumption we have made is wrong. And that will be a proof that root 2 is irrational. So everybody understands the strategy we are going to follow?
Yes, sir.
Okay, so what we do is we say that if possible, let's assume that root 2 is rational. Okay, so if root 2 is rational, what does it mean? I should be able to write root 2 as in the form of p by q, right? So I have written a by b over here. That is intentional. Okay, so normally when we have a rational number, how do we write it? We write it in the form of p by q, right?
Yes, sir.
Rational means we can write it as p by q, where p and q are integers. Okay, so if I'm saying that p and q are integers, there is a possibility that these integers may have some common factor. For example, let's take an example of 21 and 14. This is also a rational number, p by q, where my p is 21 and q is 14, correct? Can you see that it has a common factor?
7, sir.
Yes. Everyone can see that it has a common factor 7. So once you cancel that with 7, it will become 7 2s are 14, 7 3s are 21. So 3 by 2 is a simplified form. And in the simplified form, this 3 and 2, they are co-primes. Everybody understands what a co-prime is? Do you people understand? Say that again.
Their highest common factor is 1 only, sir, if they are co-prime.
Yes. Co-prime means the number themselves don't have to be prime numbers, but there is no common factor between them other than 1. So even if I say examples like 8 and 3, you see that 8 is not a prime number, but still 8 and 3 together, they are co-primes because they don't have any common factor between them. Okay. So here when I have written a by b instead of p by q, this is what I have done. That earlier it was actually p by q. Root 2 was written as p by q, but I cancelled out all the common factors such that in the simplified form, now it has become a by b. And for that reason, a and b are co-primes, where b is not equal to 0. Can everyone understand the reasoning over here? Confirm?
Yes, sir.
Yes, sir.
Okay. So that's the reason I have written root 2 as a by b instead of p by q. But remember, you can write p and q also here and just write that p and q are co-prime. It's not like a and b, it has to be written a and b. A and b are just some variables we have written. Okay. Yeah, but the idea is the same thing. A and b are such that we have already cancelled out all the common factors. So now a and b should not have any common factors between them. Now let's do some mathematical calculation on it. What do we do? This is our equation and we have done a squaring on it. So if you square root 2, you will get a 2 over here. That should be easy to understand. And this is a square by b square. Okay, then move your b square to the other side. So I can write a square is equal to 2b square. Tell me, everyone is okay up to this step?
Yes, sir.
Yes, sir.
Okay, if you have some number a square which can be written as 2 times of b square, can you see that this is an even number? 2 times of any number will be even number only, right? We don't care what b square is, but whatever it is, since we are multiplying with 2, the final result of this 2b square, that is going to be an even number. So we can assume that a square is an even number, which I have written as a square is divisible by 2. Tell me, is this statement clear? Why a square is divisible by 2?
Yes, sir.
Okay.
Sir, can you repeat, sir?
See, here I have up to this time it was clear, no? A square is equal to 2b square.
Yes, sir.
Okay. But when you are seeing this 2 times of b square, 2 times of any number is an even number, right?
Yes, sir.
Yeah. So if 2 times of b square is an even number, that means a square is equal to this number. So a square also has to be an even number. And if a square is even, that means it is divisible by 2. That is what I have written.
Sir,
Yes, tell me.
sir, we can take 2 to left side now, sir.
Yes, we can. But this is the thing which we want to prove. We want to take it such a way that we can show that a square has 2 as a factor. We want to do this. We want this result to be like this. You will understand why we are doing that. Okay. But this can be done. That's what you have to understand as of now. We have done everything mathematically. We took this result. We assumed that root 2 is rational. We wrote it as a by b such that a b have no common factors. And then I'm saying that my a square is an even number. It is divisible by 2. Okay. So if a square is divisible by 2, you know that a will also be divisible by 2. Just now we saw that theorem, right? If a square is divisible by some prime number p, then a is also divisible by that prime number p. Tell me if that makes sense up to here. Is it clear?
Yes.
Yes, sir.
Okay. So with this thing, we have proved as of now that a is divisible by 2. And then we will do some more calculation and we will prove that b is also divisible by 2. Okay. That's the strategy I'm telling you. What we are going to do next. Just now, I have showed that a is divisible by 2. Now we are going to show that b is also divisible by 2. But we had assumed that a and b are co-primes, which should not have any common factor. Right? That's what a and b should not have any common factor. And then we are showing that both of them are divisible by 2. So that is a contradiction, right? Yes. So just try to understand. This is like theory, okay? This is not logical maths which you have been doing so far. This is not a calculation. We don't have to find some answer over here, okay? That is the reason we are going in a planned manner. You might say that, okay, why did I put to that side only? Why not this side? So that's the reason, because we want to prove that a is divisible by 2. That is why we wrote it like that. Okay, it's like a theory. You have to take it like that. Same thing can be written in so many other ways, but this is the way we want to write it, so that we can prove that a is an even number divisible by 2. All right. So if a is an even number, then a can be written as 2 times of some integer c. Is that right or not? Okay. You might think, okay, why we are writing like that? I already know a is even. So why am I writing like 2c? So don't think about that right now. Hold that thought with you. Okay, why am I doing this? Because why will make it clear by seeing the remaining steps. Like I told you, this is theory. So just think about, can it be written? Can a be written as 2 times of c, where c is some integer? So let's think of an example again. Okay, think of some example. Give me one example of an even number. 20.
48.
Let's take a bigger number. Okay, so let's take 26.
42.
Okay, anything. We can take 42 or 26. So let's take 26 as of now. Now you can see that this is an even number. That means I can take 2 out of it and write some number multiplied with this. So this is 2 times of 36, 13. If you had taken 42, there also you could have written as 2 times of 21. If you had taken 36, still you can write it as 2 times of some number, 18. You understand that every even number can be written as 2 times of some integer c. Tell me. A can be written as 2c or whatever. Some you, if you like, you can call it as 2x, where x is some integer. Okay, but let's keep it c for now. Tell me, guys, does it make sense?
Yes, sir.
Yes, sir.
Okay, so since a is even, I'm writing it as 2c, where c is some integer. We don't care what the value of c is. But multiplying with the 2, it makes it even. Now, you put this a is equal to 2c in the first equation which we had got earlier over here. Okay, this one. This is what we have got from our assumption, no? A square is equal to 2b square. In this equation, you put a is equal to 2c. So we know that what is equation 1? A square is equal to 2b square, right? That's the equation. And in place of a, we have put 2c now. Tell me if this is clear up to this step.
Sir, I didn't understand that a 2c square is equal to 2b square, sir.
Okay, so this statement is coming from the first equation. Okay, it's over here. We have got this equation over here. A square is equal to 2b square. We know that already, right? Up to that, it's clear
Yes,
to you?
sir.
Okay, so now
Yes,
what
sir.
we have done, we have written the same a square is equal to 2b square. And then in this, in place of a, we have put 2c over there. We are just replacing the value of a. Can you see that? A has been replaced with
Yes, sir.
2c, okay? 2b,
Sir,
yes, tell me.
sir, instead of that, a square is equal to 2c square, you can put, sir. Then by substituting equation 1, 2b square is equal to 4c square will come, sir.
Yes, anything. That is also okay. You can do that.
Sir, both are same
Same
only.
only.
That we
Yeah.
are writing.
See, a is equal to 2c. So we know that a square is equal to 4c square. And then first equation we had got a square is equal to 2b square. So 4c square will be equal to 2b square. That is what we will get ultimately. Okay. But this kind of placing the value you should get comfortable with. Okay. When there is some equation like this, you should be able to put a is equal to something. Like, for example, when you used to have a plus b identity whole square, it is a square plus 2ab plus b square. You used to put some value of a, right? I can put a is equal to 3 and b is equal to x. So if it is 3 plus x, you will use the same identity. And in place of a, you will put 3 square like this. It's the same thing we are doing here. Is it clear? Tell me.
Yes, sir.
Okay, fine. So since we got lost a little bit, let's get back to the thing. We said that previously we proved that a is an even number, that is a is divisible by 2. That is why we have written a is equal to 2c, whereas 2c is some integer, okay? And then we put this value of A is equal to 2C into the first equation. Okay. And once you do that, in place of A, I have put 2C. So it will become 4C square is equal to 2B square. So here also you try to find out the value of B square. So move around the 2 to the other side, 4C square by 2. And you should get B square is equal to 2C square. So tell me if you understand how this calculation goes up to this step.
Yes, sir.
Yes, sir.
Okay. Remember earlier we had proved that A square is equal to 2B square. So from this, just like we said, A square is divisible by 2, no? It's an even number. Same logic we are going to use here, and we are going to show that since B square can be written as 2C square, that is 2 times of some number, that means B square is also divisible by 2. And if B square is divisible by 2, B is also going to be divisible by 2.
Sir, can we write B is divisible by A?
Say that again.
Sir, can we write like B is divisible by A?
B is divisible by A.
Yes, sir.
No, you should not think about that, whether B is divisible by A or not. Okay. See, just remember the real idea, the real plan, what we are going to do. We said that root 2 is A by B, no? And we said, I told you that I'm going to prove that A is even number and B is also even number. So both of them at least have 2 as a common factor. 2 is a common factor to both of them, which contradicts this fact that A and B are co-primes. They should not have any common factors, but I'm just proving that both of them have 2 as a common factor. That is the idea behind. So we want to prove that A is divisible by 2 and B is also divisible by 2. That's the thing which we want to prove. Okay. See, remember it very clearly. I'm telling you, this is like
Yes,
theory.
sir.
This is not like your usual maths which you do where you do some calculations. With these things, we can do so many other things. Okay, we can multiply 3, we can do cubing, we can do hundreds of other things. But that's not what we want. It's like a theory. It's what we have to understand is the strategy is to prove that A and B have a common factor. So whatever assumption we made that they are co-prime, that is wrong. And that means that root 2 will be irrational. Okay. So first, with this logic, we prove that A is even number, A is divisible by 2. And then by this calculation, we prove that B is also divisible by 2. Okay. So since A and B both are divisible by 2, that contradicts our assumption that A and B are co-primes. Okay. So this is how you will write it. You will say that 2 is a common factor between A and B. This contradicts the fact that A and B are co-primes. So why did this contradiction happen? It happened because we had made the wrong assumption. Contradiction arises by assuming that root 2 is rational. So this assumption is wrong, and that's why we can say that root 2 is irrational.
Sir,
Yes, tell me.
sir, in place of root 2, if there was any other rational number, then do we have to write A and B are co-primes there also?
Yes,
Or
actually
we
we will
can
be.
write,
No, actually we will be doing that. We will be proving that root 3 is irrational, root 5 is irrational. We will be taking that. Okay, we will be doing that. there also we will be proving, we will be showing that they are co-primes. But here, like when I was trying to prove that root 2 is irrational, we saw that all these numbers has 2 as a common factor. But for some other question where you have to prove that root 3 is irrational, let's say, then by doing some calculation, we'll prove that 3 is a common factor between both of them. Or something like that. We'll do that, okay? We'll take up more questions like that. Well, okay. See, this question is different. Like I have told you, this is like theory. You have to practice it doing like this. Whatever I have written, try to practice it. Write it a few times, and then it will become more, you'll get more comfortable with this proof. Okay. Fine. So I think we already exceeded more than 10 minutes for today's class. So let's finish it over here. We'll see the remaining thing tomorrow. All right.